We have section 4.9, number 29. 2 sine of 3 theta equals 1. And we're going to solve this. I'm going to do radians because I like radians better than degrees. But step 1 is we want to isolate the sine term. So I'm going to go ahead and divide by 2. Divide by 2. So we get sine of 3 theta equals 1/2. Now we have to figure out when does sine equal 1/2. So that goes to our unit circle. So sine is the y value. So 1/2 will be the first and second quadrant to be positive. And that was pi over 6, or 30 degrees. And then this one would be 5 pi over 6, which I think is 150 degrees, if you are doing degrees. I like radians better. So this tells us that 3 theta equals these two values. So 3 theta equals pi over 6. But remember, we could technically go around and land there later, so we say plus 2 pi k. If you decided to do degrees instead, you would say 3 theta equals 30 degrees plus, instead of 2 pi, it'll be 360 degrees k. And then we just divide by 3 to solve for theta. So theta is what? Pi over 18? 6 times 3 is 18, plus 2 pi over 3k. If you did do degrees, which is the book, I just like radians better, you would get theta is 10 degrees over plus 120 degrees plus k. Or n, right? You can use k is just a generic letter. And then we have to solve the second one. So we'll do 150 or 5 pi over 6. So 3 theta, not theta, is 5 pi over 6 plus 2 pi k. That's just again saying we can land there immediately, or we could go around and then land there. Divide by 3. So theta is 5 pi over 18 plus 2 pi over 3 times k. And so those are my two solutions. And there's technically infinite ones because you can go around and around and around the circle. If you want to match the book and do degrees, we would do 3 theta plus 150 degrees plus 360k. That's representing all circles. Divide by 3. So theta is 50 degrees plus 120 degrees k. And so then you have two solutions. Radians are going to be way more useful in calculus, so I do recommend practicing radians.